Okay, so then in this video, we're just going to finish up the last three examples. And, just to kind of reiterate and remind you that your two best tests would be like your geometric series test or your ratio test, both comparing them to 1 and finding values of x that would make sure that inequality holds true. So for this example, I think I'll use the ratio test since I don't have it's not a complete, like with an n squared there, it's not a complete geometric series. So then remember to use the ratio test. We need to make sure that we are taking the limit as n goes to infinity of the n plus first term. So absolute value of x to the n plus 1 divided by n plus 1 squared, and then the nth term, so absolute value x to the n over n squared. And so then we'll get the limit as n goes to infinity, and obviously it's not alternating, so the absolute value now becomes unnecessary. And then I'm going to break up my exponent, so it's x to the n times x over n plus 1 squared, and then when you multiply by the reciprocal, since we're dividing by that fraction, we get x squared divided by x to the n. Now the x to the n's will cancel, and so what ends up that we have left over is the limit as n goes to infinity of x times n squared over n plus 1 squared. And as n goes to infinity, again, thinking about the terms that have n's, which is this and this, that's going to be like a 1-to-1 ratio, right? So x doesn't change, so our limit's going to be equal to x. And according to the ratio test, we want our result to be less than 1. And we'll put in absolute value because we're looking for a range of values here, like this interval of convergence. So this is centered at 0. And again, if I drew like on the x, on the number line, so it's centered at 0, I could go 1 to the right and 1 to the left. And so I know that any x in that interval would make this series converge. And so right now, I just have the open-ended interval until I test the endpoints. So then let's test the endpoints. What happens if x were equal to 1? All right, let's test this endpoint here. Well, that becomes 1 to the n, which is 1. So we have the series n equals 1 to infinity of 1 over n squared. Well, that's going to converge by p series, right? So this converges by p series test. And so therefore, I can now include 1 as one of my, that'd be like a solid dot there, right? So that endpoint works. And then what happens if it's x equals -1? Well, then we get the alternating series, n equals 1 to infinity of -1 to the n over n squared. And that also can be shown to be convergent. And for this example, I would talk through it more than I would write. But if this were a question on the AP exam, you'd want to be a little bit more rigorous, saying, how do you know it's convergent? Oh, alternating series test, right? Alternating series. And, you could show that the limit of the terms goes to 0 and that the series without the absolute value is decreasing. So that means I can also include -1. So that's closed-ended on both. Or if you think about it as interval notation, make 2 hard brackets. Okay, so it's up to you. Like you can, for 7 and 8, if you want to pause the video and try it on your own, and then come and see how it went. Or if you want to just keep following along, that's fine. So again, I could use a geometric series, or I could use a ratio test to kind of analyze this. And so I think what I will do is maybe this time I'll use like a geometric series because I do have 2 components that are like powers of n, right? So and this will converge as long as that ratio is less than 1. Now, if this n right here bothers you a little bit, then we can solve it also by using the ratio test. So if that, like, maybe you want to try geometric series. I know I said that, but no, let's just do ratio then, just in case. So it's the limit as n goes to infinity in the absolute value. So I can then I'll eventually be able to get rid of this alternating part, x plus 2 to the n plus 1 when divided by n plus 1 times 2 to the n plus 1, and then divided by absolute value, -1 to just the n of x plus 2 to the n divided by n times 2 to the n. Now, in this case, the absolute value is going to go away nicely. And again, I'm going to rewrite that x plus 2 to the n times x plus 2, since I have an extra one. And then there's n plus 1. And then there's 2 to the n. And then an additional 2. And then when I divide by that, I'm going to get the reciprocal. So n times 2 to the n divided by x plus 2 to the n. And what ends up happening, oops, I didn't need the absolute value there, x plus 2 to the n. And so I know at least the x plus 2 to the n cancels with x plus 2 to the n. And it looks like I have 2 to the n canceling with 2 to the n. And so then if I take a look what's happening, I'm going to rewrite this because I want to make sure that it's very obvious. I'll put kind of like things together here. I've got n times x plus 2. And then I also have n plus 1 times 2. Now, as n goes off to infinity, I know that this much of it will approach a ratio of 1. And so then what ends up happening is I have just x plus 2 over 2 left over. And I want to make sure that that x plus 2 over 2, I want to make sure that that is less than 1 according to the ratio test. So I can open up my interval. So it's -1 is less than x plus 2 over 2, less than 1. Multiply both sides by 2. So right now it looks like my radius of convergence is 2, and it's centered at -2. So even before I solve this, I'm centering at -2. If I go 2 to the right, that would be 0. If I go 2 to the left, that would be -4. And again, subtracting 2, I get -4 is less than x is less than is less than 0. So I knew that from an inequality point of view, but also from this graph up here on the number line. So at least it gets me open-ended. Now I have to check the endpoints. So what happens when x is 0? So when x is 0, our series becomes 2 to the n. So we get -1. Sorry, it alternates. So we get the series n equals 1 to infinity of -1 to the n, and then times 2 to the n over n times 2 to the n. Well, your 2 to the n's are going to cancel, and this really is going to now represent the alternating harmonic series. And I can prove that easily converges by alternating series test. So again, I don't really have a rigorous proof here like I would for the quiz, but it converges, I could say, by alternating series test. And just make sure you know that you have to show that the limit goes to 0 and that the function is decreasing. So the fact that x equals 0 converges means I can now underline that. So at least I know on the right side it converges. And then the left endpoint, when x is -4, now we get -4 plus 2. So now we get -2 to the n. So n equals 1 to infinity. So we get -1 to the n, and then there's -2 to the n, and then this is all over n times 2 to the n. Now, before I can cross out those 2 to the n's, I need to factor out that -1. And so when I do that, so 1 to infinity, so I have -1 to the n. I'm factoring out a -1 to the n there, and then I have 2 to the n over n times 2 to the n. Well, the 2 to the n's cancel. -1 to the n times -1 to the n, those will always be positive, right? Because when n is even, it's positive. When n is odd, you have 2 negatives, they become positive. So this is equivalent to just our harmonic series, and it doesn't alternate. So I know that this diverges by p-series test, right? Or by harmonic series, whatever you want to explain there. And then once you know it diverges when x is -4, we keep that one open. So in interval notation, -4 to 0. So this would represent the interval of convergence. And again, any value of x. So on the number line, here's 0 and here's -4. So it's open-ended on -4, but closed on 0. So any number there, you could put in for x and it would converge. So if you liked x equals -2, great. If you put x equals -2 right here, but that's kind of trivial because -2 plus 2 is 0. I forgot about that. So yeah, you get a bunch of zeros. Great. But let's say you did -1. -1 fits an interval. So that value would work. If you like -3.5, that works. Our goal is to find all of the x's that you could put in right here so that when you add it to 2, you would still be able to find a series that converged. Okay, so then we have one more example. And again, feel free to do this on your own and check back or look here. Now, it's real suspicious there's no fraction, right? So as n is getting bigger, these terms are getting pretty big. So I don't have a lot of hope that this is going to converge for anything other than just where it's centered, which is 1/2, right? Because that's what would have made this equal to 0. But we can quickly verify that. The limit as n goes to infinity of absolute value of n plus 1 factorial, and then times 2x, a little slow there, 2x minus 1 to the n plus 1, and then we'll divide by just n factorial times 2x minus 1 to the n. Okay, and then, n plus 1 factorial and n factorial cancel except for the very first term. So the limit as n goes to infinity of just n plus 1, and then that tail end cancels with the rest. And then 2x minus 1 to the n, that'll cancel with all but one of these up here. So then we have another 2x minus 1. So we want to think about what's happening as n goes to infinity. This thing continues to increase, and so we get infinity for our limit, which is greater than 1, right? And so that means that this will diverge for every value of x, other than just the trivial one when x is 1/2. So again, we can show that by the ratio test that it's going to diverge for all values of x. Then there's no interval of convergence. Our radius is 0, and so in terms of finding an interval, it's only at x equals 1/2. So there's really no interval, and it only converges when you have the trivial center of a bunch of zeros. Only converges for x is equal to 1/2, and the radius, like we said, would be 0, and therefore it just converges at that one point. So okay, so like I said, really the ratio test is a great one to use. If you feel it's a pretty simple geometric series, you could use geometric series, and then again, double check the question. Is it looking for the whole interval? So you have to check endpoints, or is it just looking for a radius? And then you don't have to check the endpoints because the radius would just be the length at a particular, x value that would be the center.